Okay, so in this video we're going to talk about one-to-many relationships. We've been dealing with a single table at a time in our databases thus far, but we're kind of stepping into some new territory. We are dealing with the relationships between multiple tables, so now multiple entities. Typically, a relational database is going to have many tables in it. Uh, Our examples are a little bit kind of trimmed down because we're in the beginning stages and we're learning. Uh, but when you get out there and you're dealing with lots and lots of data, there's not going to be just one straight list of data, and you're going to need to know how to deal with having data interact with other data. Um, so the most common way that tables are related to each other is called a one-to-many relationship. We're going to deal a lot in the one-to-many relationship area for the next little bit. We're also going to learn about many-to-many relationships and one-to-one relationships and recursive relationships. For now, let's stick to the one and work our way through it. One-to-many relationship will describe a relationship between two tables where one entity belongs to the other. For example, we're going to be looking at a sort of social networking type video sharing website example shortly, where users will have accounts and those accounts will have videos. And today that's all we're going to look at directly, but we're also going to talk about how those videos will have comments and likes and dislikes and all the ways that we might want to deal with storing that data and having it interact. Some of the key terms that we'll use are parent table and child table. The table that belongs, or the entities that belong to the other entities, will be considered the child table. Right now, like I said, we're going to deal with just two tables. However, keep in mind that you're not limited to having a table be just a parent or just a child table in a single relationship, but the same table could be a parent in many relationships and a child in many relationships. It's just a matter of how one entity relates to all the others in a database. So we're going to start with this case, like I mentioned earlier, the video sharing website. And I'm going to be using it as an online example for the rest of the term. It's simple but functional, meaning that we are dealing with a very lightweight version of a video sharing website. So it's not going to be loaded up with fields. We're going to keep our tables short and slim so that we can work with them in a learning environment. What that means is if you're thinking, well, what about this? What about the uh, description section? What about the categories? What about the tags? Those kinds of things. They're definitely things that you would think about, and we may consider some of them as we work our way through this scenario. But in order to keep things in kind of focused on what we're learning, I'm trying not to overload our tables with too many different ideas all at once, and I want to stick to just a trimmed down version of it. So this database, it's going to consist of accounts. So users will come and they will register for an account. So think when you go to YouTube, you need to have a Google account. When you go to Facebook, you need to get a Facebook account. Same thing with Instagram. Any social networking platform that you can think of will need you to register for some sort of an account. And this is sort of what we're going to simulate in our account entity. In our case, we're also going to be looking at shared ad revenue. So we're going to act as if this 2Ube website is going to be splitting revenue 50-50 with the users who are running these accounts. So if they get a lot of people looking at their videos, then everybody wins. We're also going to be keeping track of videos. And for today, those are the only two entities we're going to focus on. Eventually, we are going to expand out and include other entities in our scenario. For now, we're just limiting it to accounts and videos. And the videos are obviously what the users upload, and there will be statistical information attached to the videos as well. So this is roughly what our new design looks like. I've taken out some of the fields here. We'll look at it a little bit closer shortly. In the next video, I'll actually go through adding the columns and stuff to a table design so we can look at the new steps in the table design. And we'll also look at how we're going to draw this crow's foot notation, what it means, and so on. This is called crow's foot notation, by the way, and we'll be using it in a database design chart. So we've done our entity models to date. Now, a database design chart is just a conglomeration of multiple entity models where we also describe the relationships between them. And for our class, to keep it, again, focused, we're doing just a simple crow's foot notation, which is an industry standard, but there are other industry standards out there, so try to keep kind of focused on just this one area, because if you were to go to Google and say, how do I make an entity relationship diagram, there are at least 20 different ways that it could be done. We'll use this simple way. We've been working toward this all term, and now it's kind of time to get past that zone where it kind of feels like we're just going through the motions. And now we're going to start really getting into the critical thinking side of things. We're also going to be that the crow's foot notation isn't the only thing. We're not just describing a relationship, but we have to enforce that relationship inside of SQL. So we're going to be learning how to code foreign keys. Foreign keys are the means of connecting our two entities inside of our database, such that a database can easily figure out which entities in the child table belong to which entities in the parent table, or worded differently, which records in the child table belong to which record in the parent table. We will use this foreign key constraint. Just like a primary key, we need to create a column, but the column alone doesn't provide the constraint. So if we just put a foreign key column and we don't put a constraint, then we can put any value in that foreign key column, and it won't necessarily have a reference to a primary key in the other table. So we put a constraint on it to make sure that if somebody enters data into this table, that it will always have a related parent table. Otherwise, it'll return an error. Each record will have a value in this column. For now, we're always going to make sure we have a value. It's not something that we can leave null. We're going to set that as a rule when we create the column, and I'll explain why over time. But for now, we will always have a foreign key once we have a child table. Now, I'm going to come back to these final notes later on in the series, but just to kind of give you a couple of quick pointers. Each of our documents will change a little bit, including our initial create table code, and eventually we'll have to look at some gotchas with how we write our insert statements, and then finally we're going to learn how to join together data from two different tables in a single output using a select statement. So we're going to have to make sure that in the database design we don't list the foreign key column name in the child entity model. We're going to list the foreign key column in the table design, but we don't want it in the entity model because an entity model is a representation of a single object, and it doesn't want these foreign elements. That's why it's called a foreign key. It's something that doesn't really belong to the child entity. It's just a means of saying what the child entity belongs to, if that's not confusing enough. So it's just sort of how we annotate our database designs. We don't put the foreign key in our entity models. The table design, on the other hand, it's a little more detailed, so we do put the foreign key in there, and we mark off in our constraint column that it is a foreign key and that we don't want it to be null. Our create table statement, you'll see the code. I'll show it to you, and then we'll discuss it again later on.